2.
Yes. Hello, everyone, and a very warm welcome to the kickoff event of SensUs Student Competition 2026. Whether you're joining us here on campus or watching us through the live stream, we are very happy to have you today with us.
It's amazing to see so many passionate, curious, and driven students coming together with one common goal, pushing the boundaries of biosensor technology. And honestly, this energy is exactly what makes SensUs so special every single year.
We've got an exciting program planned for you today. First, we're going to start with a general opening, followed by a presentation given by one of our sponsors, BombSense, who will show you how you can turn an electrochemical idea into an actual commercial product.
Then, we'll hear from Maarten Jongsma, who will talk about monitoring Parkinson's symptoms like tremor, dyskinesia, and bradykinesia using smart technologies, which will smoothly lead us into our panel discussion with experts with different perspectives on Parkinson's.
And after the panel, we will have one last presentation given by one of our sponsors, Photon Delta, where they will be sharing their latest developments and innovations. And we're closing the evening with a networking session where you will have the chance to connect with experts and innovators. So we hope you're excited as we are. To officially kick off this year's competition, I would like to welcome on stage the chair of SensUs 2026, Huyam.
Hello everyone, and welcome to the SensUs 2026 competition. We are thrilled to have you join us on what promises to be an exciting and meaningful journey. By joining SensUs, you've chosen to take on a real-world challenge, one at the intersection of engineering, biology, medicine, and impact. You didn't sign up to follow a recipe. You signed up to create something new. SensUs is not just a competition. It is a platform where you build and design your own continuous monitoring solutions for problems that don't yet have clear answers. It is an international community where ambitious student teams challenge each other to go beyond what is taught in the classroom, where you connect with professionals from around the world and where you'll be asked to bridge the gap between technology and healthcare. And as you work towards your goals, don't forget to enjoy the journey itself. The growth, the teamwork, and the challenges that will shape you along the way. Our shared vision is bold, a world where continuous biosensing enables real-time insight, real-time control, and healthcare that adapts. This year's challenge reflects that ambition. You'll be developing continuous biosensing solutions for levodopa for Parkinson's disease, a medication where timing and dosage vary greatly from person to person. That uncertainty has real consequences for the daily lives of millions of people. It is a complex problem, and there is no single correct solution. That is why you are here. Throughout the competition, you'll be competing against 20 different teams from 14 different countries across 4 different continents. You'll be working towards 4 different awards. First of all, analytical performance will be awarded to the team whose biosensor performed best at the Eindhoven testing event. Second of all, innovation recognizes the team with the highest technological novelty in their biosensing concept. Third of all, the Translation Potential Award focuses on the future because real impact doesn't stay in the lab. So, what are your plans to bring your biosensor from a prototype to a product? And then, public inspiration celebrates the teams that best inspires the public with their sensor. Because impact also means being able to tell your story. As SensUs continues to grow and evolve, we decided it's time for a new and fresh design. We're proud to launch our new website today, a new design that better reflects who we are as a community. So definitely feel free to take a look and check it out today. Behind the scenes, the SensUs organization will do everything we can to make this experience impactful and memorable. I'm proud to introduce the SensUs team. 24 highly motivated students at Eindhoven University of Technology from 8 different majors, working hard to make this competition a success. We're incredibly excited to see what each of you will come up with, and of course to meet you in person at the end of August. To give you a glimpse of what lies ahead, let's take a look at the recap of last year's Sensus edition.
Hello everyone and welcome to this special 10th edition of the Sensus Student Competition. Here at Sensus, student teams from across the globe step to the forefront of innovation, creating sensor solutions that can impact healthcare, research as well as industry.
My name is Osha and I'm the chair of Sensus Organization 2025. What makes this competition unique is that it's organized for students by students. We set the challenge, we create the rules and build this platform for young innovators to push the biosensing forward.
Yes, we can start! The teams have developed sensors for the continuous monitoring of creatinine, for improving the lives of patients with kidney disease. Each sensor is tested live in the competition to see if the challenges are met.
At Sensus, innovation happens through collaboration. It is built on dialogue between students, clinicians, industry, and the patients.
Being part of Sensus definitely taught us communication and teamwork and how important those are. So it led to very interesting moments, having to work with people who have different styles of communication, different backgrounds, different ideas of what a good team is.
It was also very valuable to see a slightly different point, like how much goes into producing a sensor, generally producing a product. There's so many hidden facets and depths that you don't really appreciate or you realize exist and need to be put into it. So that was very interesting to see.
So CSCM, we are a research and technology innovation center. So we decided to support the Sensus competition because first it allows us to also see what's happening on the student side in the sensor development and what are the learning there. And also because it allows us to attract students that are interested in biosensor development in the future.
As a kidney patient, it's very interesting to join this day because the view of the patient is very important. Compared to last year, I see that there's more interventions with patients. They have contact with patients. And also it's very important to think about the group of patients that you want to work with. So it's a big difference if you have pre-dialysis people or people who have just been transplanted. That's a big difference. And I see that differentiation now, and I think that's a good thing. It's very nice to see those motivated students working on new developments for people like me. I hope to see a lot of it in the future.
Welcome everyone to the 10th edition of our Sensus Innovation.
That was a great look back at last year's competition. It really highlights the creativity, the teamwork, and especially the technical depth that teams show every year. Over the past 2 years, the competition focused on acute kidney injury, a critical healthcare problem that required innovative biosensing approaches. This year, we're shifting our focus to another important and impactful theme, which is Parkinson's disease.
So why this theme? What challenges does it present? And how can biosensing contribute? These are the questions guiding this year's competition. To share more about the vision behind Sensus and the motivation for the theme, we'd like to invite the founder of Sensus, Menno Prince, to the stage.
Thank you very much. So I'm very glad to see you all here, that we're all here together to kick off Sensus 2026. And as I said before, Sensus is organized by students for students. And it's also the students that determine every year the theme of the Sensus competition. Over the past 10 years, we looked at the kidney, the heart, antibiotics, rheumatism, epilepsy, influenza, acute inflammation, brain injury, and initially point-of-care testing, and now the last 2 years, continuous monitoring. And for this year's edition, the students decided to focus again on continuous monitoring to support this future perspective of wearable continuous monitoring sensors. Now the students looked around, they spoke with patients, they spoke with experts, they spoke with university professors, they spoke with companies, and then they proposed this topic of Parkinson's disease. It's a disease that affects millions of people globally. It's a very serious disease because it's progressive and there's a gradual loss of more and more cells in the brain, which affects not only the physical experience of the patient, of the person with Parkinson's disease, but also the mental state. Unfortunately, Parkinson's disease cannot be cured. And for many patients, symptoms can be managed using levodopa treatment with the right dosing and the right timing of levodopa medication several times a day. However, as the disease progresses, this becomes more and more difficult over time. And that's why SensUs focuses this year on the development of sensors for the continuous monitoring and better treatment of people who are having Parkinson's disease. So today we are very excited to kick off SensUs 2026 together with you. I wish you all a great learning path, and we all hope that your SensUs journey will be very inspiring, that you will come with new ideas and with innovative concepts to improve the lives of people with Parkinson's disease. And I'm getting a tip. Sorry. Oh, sorry. Thanks a lot. And now I'd like to introduce the theme movie of the healthcare topic of SensUs 2026.
My name is Els. I'm 68 years old and I'm married with Kees, my case manager. I like to cook. I can't smell or taste anything, so I thought maybe it's for me it's good to cook several things. It's my pleasure instead of smelling and tasting. Since I'm retired, I had to stop work because of my Parkinson's.
Progression starts when dopaminergic neurons begin to die, with symptoms including irregular sleep patterns, slowness of movement, tremors, depression, and anxiety.
In September 2019, I was diagnosed with Parkinson's. My hand got a tremor, my concentration wasn't good. My biggest challenge is to stay by my own soul. I'm not a victim of Parkinson's. I have Parkinson's, but I'm not a victim. I started levodopa, carbidopa when I was diagnosed, and I had to build it up. I realized how I can smell things, I can taste a bit, my stiffness was better, I could feel the wind on my skin outside.
As Parkinson's disease progresses to later stages, the therapeutic window for levodopa narrows, resulting in a return of Parkinson's symptoms. Continuous levodopa monitoring can help personalize the timing and dosage of levodopa, resulting in a more effective treatment.
To at any point know your levodopa level, like at a point, would that be helpful? Or?
I think so, yeah, I think so. I don't have to think about it myself, and I don't have to feel bad because I forgot a dose.
Insightful introduction. Now that we better understand this year's theme, we move to our first sponsor spotlight. PalmSense is a longtime partner of SensUs. By providing a comprehensive range of instruments for electrochemistry, they are vital in making electrochemistry easier, more portable, and more accessible for researchers, entrepreneurs, and students like us. PalmSense has prepared a short video showcasing their OEM potentiostat solutions and how they support the transition from research to real-world applications. Let's take a look.
Turning an electrochemical application into a commercial product is easier said than done. Your resources are limited and speed is essential as the time to market is now. Our OEM potentiostat products allow you to translate your sensor application quickly into an end-user device. At PalmSense, we provide two types of OEM products: potentiostat modules, which can be integrated in your product, and market-ready solutions, where we provide an end-user product the way you need it. The first OEM product is the MStat module. It offers a wide range of electrochemical techniques such as cyclic voltammetry, chronoamperometry, electrochemical impedance spectroscopy, and many more. MStat modules allow for a wide range of communication options, including USB, Bluetooth, and TTL. The MStat module has been designed in a way that it's easy to prototype by connecting it to an external microcontroller like an Arduino. You can easily start prototyping using the MStat development kit and by using one of our many code examples. We also provide market-ready solutions. We deliver a full end-user potentiostat or reader tailored to fit your application and brand, starting at low quantities. You can customize your market-ready solution by selecting the housing, the module, the battery, and wired or wireless connectivity. Our solutions will help you to accelerate in making your electrochemical application ready for commercial use. PalmSense can deliver a custom app for your sensor application, or you can make it yourself using our software development kits and code examples. PalmSense is an independent company and official partner of Analog Devices. We are active in more than 100 countries. Contact us for more information or visit our website, palmsense.com/OEM.
Yes. Thank you, PalmSense, for sharing those insights. Next on our agenda, we have a presentation that will be given by Martin Jongsma. He will present an innovative application that uses smartwatches to continuously track Parkinson's symptoms. His work demonstrates how wearable technologies can support both patients and clinicians with meaningful data-driven monitoring.
Thank you for inviting me to give this talk. I know Mano, and I heard about this initiative, and it happens to be that 2 years ago I was diagnosed with Parkinson's, and I became really interested in ways to understand this disease and also to observe my own symptoms in a way so that I could make conclusions about it. And well, there were some apps available. So before I developed the BD Trends app, I worked with other ones, and I will give you the whole history a little bit. But the idea is that you can do quite broad PD symptom monitoring. So the background of me developing this app with actually my family, I should say, actually my son and daughter, they helped me a lot because I'm not good at, I cannot do a program and app myself. But there were already apps around, and they work with smartwatches, which offer the opportunity for patients to continuously follow their own symptoms. And this was really accelerated when Apple published in 2021 a paper on a specific API that could recognize the tremor and dyskinesia of PD patients, because we all move around, but the PD tremor is something different. It's something between 4 and 7 hertz that's happening, and focusing the API on that aspect really helped to understand what's going on. Of course, many people, not everyone has an iPhone and an Apple Watch, so there's interest to also do this for Android-based systems, for example, but they have not progressed so far. So I was dependent 2 years ago on what was on the market, and this was Strive PD and Parky. Well, I was in the early stage, so I didn't have much money, so I was going for the free one, which was Strive PD of Rune Labs in the US. When I started using it, I quickly noticed that there are some limitations. For example, there are research apps on the market, or not on the market, but they are used by the university, so everything is covered there, but they typically don't give you, as a person with PD, you don't see those data. It's all blind, and that's what they like, but it's not what I like as a person with this disease. And so this is something that's interesting for me, but of course also for my doctor. He would actually like to see my symptoms. When I just go there for 10 minutes, he has very little opportunity to really understand how I progressed or what worked or didn't work with the medication. So for this, and also for your new initiative to make a levodopa sensor, it's actually really important, I think, to be able to match whatever you monitor in terms of levodopa with symptoms. So it's with that comment on the initiative that I contacted Menno about it. So as I said, there's currently subscription-based apps that you can find in the App Store, but they basically expect insurance companies to pay for it, and a lot of them don't manage to get that work going, and it essentially means that you're blocked from some apps that are maybe really useful to have, but they're just not accessible. So it became a little bit my mission to develop something that will be free and available and give you the best data. Also, those apps are typically will upload all the information to the central database, and making it very hard for you to access data. Also in the SensUs program, for example, you could try to have an app like that, but then you have to go through a lot of trouble to get the data out. Then finally, there is this point that those apps are in my opinion, failing to show maybe the amount of the duration of tremor, but not the intensity. So they simplify things because they think the patient otherwise, or the person with Parkinson otherwise doesn't understand. But yeah, you're also losing a lot of actually really relevant information. Because sometimes I notice that, for example, you take a medication, it will switch from a mild tremor to a light tremor. They call it slight tremor. It's the same amount of tremor in terms of time, but not of intensity. So the medication is doing something, but you wouldn't see. So then there is there's other aspects, the longitudinal aspect. For example, I now have a 3-year view in one graph, and that is actually wonderful because it's a progressive disease, so you really see what's going on in time. Well, and yeah, so maybe that's enough for the moment. So here you see what such a sensor can do in terms of day symptoms that it gives you. So you can look at 3 years, but you can also, with a proper app, you can also just look at 10-minute detail. Actually, the measurements are taking every 2.5 seconds, but then typically when you process those data, you go to 10 minutes or 1 hour, or the average of a day, or the average of even several days. And yeah, so I don't have a pointer to tell you, but the different colors represent different types of tremors or dyskinesia, and there are different ways of showing it, but the fluctuation you see is actually typically what happens when you take a levodopa medication. The tremor, for example, will go down, but the dyskinesia of too much levodopa will start, and this is one of the issues with this particular levodopa medication. Well, I contacted these companies and I said, I want to have the raw data, the raw data back, actually. I sent it to you, but I want it back. And they said, okay. So they were willing, at least at Strive PD, they were willing to give me the data, but it's actually quite complicated. So we had to arrange, my son helped with that, to arrange a data on our own server to get the data, and then I could open my Excel and access those data. But of course that was not perfect. By the way, Mr. Anthony here is actually myself. It's my second name. That's something you will find with PD patients that are still in a job. They don't want to make it make it fully public, but nowadays I wouldn't mind. So I also responded, so I started to develop ideas on how this sensing could be improved. So I also responded to something that was published in the Dutch Parkinson magazine, for example. And I said, well, maybe we should develop an app that is free to the community and giving you the best data. So my son, he's really quite good at this, so he after having helped me with getting the data into my Excel file, he spent a few weekends building an app, and we called it PD Trends, and gathering the data that is for tremor and for dyskinesia, but also my neurologist asked, yeah, I also want to have bradykinesia data, so we add those in, and they're actually, you can download this kind of things like speed of walking, step size from the Apple Health app. So that can all be collected, and the idea was, and my daughter built the website PD Trends, so you can view some of the aspects about it. But it's not finished yet. It's just we are just starting, and I'll explain you a little bit more about that. So the why and for whom I think is already clear. It is principally, first of all, for the people with Parkinson themselves, but it can be very useful to talk to your clinician and to tell you, well, the medication worked, you can just see it here, and also for SensUs to provide you with data that can support scientific questions. So how does it work? You can see here that this is the screen capture of one of the tremor views. So the different colors are different intensities, and they all add up to that. And the highest peak is when I stop my medication, just to tell you, and also the other ones are when I didn't use my medication. But we look at there's a data tab in which you can update. You actually collect the data from your watch to your phone. There is, but there's also an export option so that you can actually get these data in 10-minute detail if you want. Then there is the so-called pattern app and in a pattern view, and there you get the data from, for example, 1 day per hour or per 10 minutes, but averaged for like that day or for a week or for a month or more. And that is also very useful because then you can see the effect, for example, of medication. And then there's the progression one, which gives you the overall time effect. Here you see around 3 years already. What I think is very important that should be added is that there should be something that gives you a log to tell you, okay, how did I feel? What is the reason for maybe a high tremor amount? And this can be used to maybe with AI can interpret all these things and make a story out of that to understand how the tremor symptom relate to what has happened in your life, and then can make an advice maybe exercise more. And finally, what I think would be a very good addition is that there would be a reporting addition to it. So now it gives you the symptoms, but it's to interpret it, there should be an automatic reporting. Okay, just to show you, if you have the view of the app, you can click the kind of traits you want, and as I said, it's tremors, but it's tremors in different intensities. So when I have a lot of tremor, it would record that as strong or moderate, but sometimes the tremor is just hardly visible, and that would be considered slight. Besides tremor, there is also this dyskinesia, so that's when you have too much medication. It doesn't happen with me yet, but you can see that with patients that are in a later phase. And there's aspects like movement, and which are bradykinetic effects, that you start to walk more slowly, your steps become smaller, your balance becomes worse, and those can also be chosen to be seen in a graph. And similar for sleep activity, so that's of sleep quality, also an important thing that contributes to symptoms. Well, there are additional things you can add to this whole principle. And the way to download this is the data tab, and if you would use the app now, I can give you access to this. Then you can download the data to a cloud or to your own PC if you would need to. Currently, it is day average and hour average. I think for your application, you would also want 10-minute average, and we can add that if you want. Here you can see in a progression image how the data look. Where the white area is the area where I didn't take any levodopa, so you can see my symptoms go up. But this is a whole year. So in my case, I'm stage 1. You should understand it takes several weeks for the levodopa to become maximally effective, but also to lose its effect. So at first I lose the effect, so the tremor goes up. Then I start taking medication 3 times a day, but it takes 4 or 5 weeks to really have the maximum effects. This is not the kind of thing you are most interested in for your levodopa sensor. I think you want a later stage patient for that. Well, here you see the 10-minute graph. So this is the pattern of one day. I indicated on the right where I took my 100 milligram of levodopa. You can see that because I'm stage 1 patient, actually the levodopa appears not to work, but you just saw it does work, but it just takes longer. So it's still important to take it. But you can see that if you just have a single day data, that it's very fluctuating. So if you would use this kind of symptom measurement, I think you should do averaging. You can do averaging to an hour, or you average, for example, a whole week of data. Then you can use the 10-minute data still and have a reasonable indication. And it may differ actually between patients a lot, because everyone is different. So I may be very fluctuating because whereas another patient may be very crystal clear in the response. Well, that's all I wanted to say. So we are halfway there with this PD Trends app. I know I'm very happy what I have, and I think it's already useful for your program. But I want to add other aspects to it, and maybe we can work together to get a grant to make it work, or you as a student can really be helpful as well. I look forward to the collaboration. Thank you. That's all.
Thank you, Martin, for that very informative presentation. We now continue with our panel discussion, where we'll explore the topic from different sides. Let's take a moment to welcome our esteemed panelists for this session. First of all, Ruud Overis, a person with Parkinson's disease. Then Tessa Pierbolte, PhD candidate at Radboud UMC. Ekaterina Bedina, a researcher specializing in Parkinson's disease, Parkinson's biosensing, and of course, Martin Jongsma. Together, they'll share their unique perspectives on Parkinson's and the latest advancements in the field.
Of course. Oh, you have your water. Yep. Yes. Good afternoon, everyone. First of all, thank you all for being here and being part of this kickoff and this event. We are very excited for this panel talk, especially that because now we're not using slides and theory to learn more about Parkinson's, but now we're bringing together the people who study, who also live and also build solutions for Parkinson's disease. I would love to start with you, Tessa. Your research focuses on at-home monitoring, which sounds great on paper, but when it hits reality, then things can get messy. So can you share one example where something that looked perfect in theory and just didn't work in practice, and what was the reason?
That's a very good question, thank you. Well, actually, we are currently developing such a remote monitoring intervention. And luckily, we are very aware of the risks we can take. So the study has to be started on March. But what we did to actually prevent this is that I started this whole intervention with some literature studies on early signs that we needed to detect so we can prevent unnecessary symptom worsening. But then I thought, okay, well, I have this perfect thing already completely thought out. I involved the neurologist, for instance, and he is also completely in line with it. And then we have the patients, and I think that one is sometimes really overlooked. What is relevant for them, and how can we motivate them? Because they are the ones that need to wear the sensor or fill in the questionnaires. And I think that one is very important. So what I've learned is that you can have a great idea and think about how you can measure it, but that's also very important that the way you measure it aligns with what the people with Parkinson's can do and will do. And especially when working with people with Parkinson's, they have those symptoms, and those motor symptoms can also prevent them from being able to use an application, for instance. So also test your application. It can be the small details like the size of the buttons you choose, or the color contrast you choose that matter, and that can help your intervention to be really used in practice.
Thank you. Just one question. So was it the first step that was hard, making the patient use the biosensor, or just more keeping them using the biosensor?
I think it's both. So I think it's very important that people understand and really want to use your monitoring device, and if you want people to use it, then it's really important to know what's relevant for them and how you can present your sensor to them, that they understand why it's relevant. So that goes both ways. And also you want them to use it for a longer period of time, and then it's very important that they can continue using it. So you might also think about how can we keep it relevant. So not only for the first couple of weeks, but how can we keep them motivated to use it? For instance, by integrating some self-management recommendations that are personalized based on the data the sensor measures.
Yes, thank you.
Ruud, you are a Parkinson's patient, and you are also the founder of Parkinson's to Beat. So can you tell us about your experience as a patient and what Parkinson's to Beat means to you?
Yes, of course. I was diagnosed with Parkinson's 9 years ago and completely changed.
Can you use the microphone?
Sorry.
Yeah, it is already on. Yes, thank you.
Yes, of course. I was diagnosed with Parkinson's 9 years ago, and I completely changed my life. Before that, I worked in dynamic, high responsibility roles at companies like KLM and Philips. Jobs that demanded flexibility, sharp decision-making, and enormous energies. And then, almost overnight, I became unreliable. I was co-responsible for a major project worth around 200 million euros, reporting directly to the CEO. Yet I found myself crying at my desk, unable to prioritize, plan, struggle with incontinence, and even losing the ability to write. It was a complete nightmare. I founded Parkinson to be to raise money for fundamental research with the hope of one day eliminating Parkinson's. I cycled nearly 10,000 kilometers in 80 days, organized golf tournaments, and very ambitiously even launched the Parkinson Games. Over time, I realized that curing Parkinson's is a long-term goal. So Parkinson to Beat defined a clear short-term mission: get more people with Parkinson moving, because movement slows the progression of the symptoms of the disease. We began supporting sport clubs to become more accessible, welcoming, and knowledgeable for people with Parkinson's. But we also learned something crucial. The hardest part of living with Parkinson's isn't just the symptoms. You can cope with that. It's the unpredictability. One day the medication works, the next day it doesn't. It wears you down. It affects your entire life.
Thank you.
Thank you so much. My next question is going to be for you, Martin. So you're in such a unique position. So you're both a scientist and a patient, and you've already explained that in your presentation about the limitation that apps already are on the market had. But most people would usually just download the apps and just accept it. But what was really the main reason for you that you thought no, I need to build my own app?
Well, I'd read the paper, and so I thought there are more data there that could be used. And at first I was just expecting that there would be more information in there. So, and indeed I found, and I communicated in several. I mean, we had all kinds of exchanges, also live on Teams and so on. And I was hoping that they would implement that. So it was the first year my effort was in that direction, but then they didn't. So I was all the time still working with my Excel every day. And I noticed now with the app, now that my son gave it me for my birthday, more or less, last year, and I'm no longer needing the Excel file. So it's really an improvement, and but I still want to associate it much better with what I do in life, like exercise or medication or supplements. For example, the initial reason to contact them 2 years ago was that, oh, I noticed a huge dip in a stable dip in my tremor, and I said, did you change the algorithm? That was my first question to them, and then no, we didn't do that. So and also I contacted Radboud. What could explain this real stable decrease? And then they said, yeah, it could be something. Could it be? I said, could it be something that I changed in my diet? And at that time, I thought it was the probiotic, but I also changed to these mung beans. And only recently I learned that these beans, they contain levodopa.
Oh, okay. Now you know the reason.
And so I think the stable change is just because my breakfast already for 2 years is actually with these mung beans. And it has a low dose of about 100 milligram of levodopa. So in hindsight, I think I can explain. And that's the citizen science thing about it. Now I would like to tell people, okay, do the same thing. You use your watch, see if something happens.
Yeah. Thank you so much.
So, Ekaterina, from your perspective, what are some of the biggest scientific or engineering challenges that come with designing biosensors or reliable biosensors, especially for continuous monitoring?
Thank you. That's actually a very, very relevant question for development of sensors for continuous monitoring. We want them to first be able to provide us a continuous readout, and for that we need to have binders that can recognize the molecule of interest and be able to not only bind to that but also unbind. And that's a tricky requirement for the most of the binders because they are not developed for this application for this requirement. So that's the first challenge that I would address. And secondly, we need to make sure that continuous sensors can actually read out robustly and also for the long duration. And for that, we need to make sure that the stability of the sensor is really well investigated and improved. Here we saw with presentation of Marta that he is monitoring the motion movement for the duration of several months. That is a challenge for continuous sensors. So then we would need to investigate different conjugation strategies and methods of functionalization of molecules on the surface and different strategies to prevent non-specific sticking of other components that we can find in the matrix, for example, blood, that we want to test, so we can recognize the molecule levodopa really reliably, specifically, continuously for a long time.
Okay, thank you so much.
Next, I have a question for you. As a patient, you have already used biosensors, so what would be an important feature of a biosensor for you?
No, I've never used a biosensor before, but I did, however...
The microphone.
No, I've never used a biosensor before, but I did, however, use two types of smartwatches, especially designed for Parkinson's, Verily and Parkinson's smartwatch. And yes, I think a biosensor for me would be definitely a game changer. The most important features would be accuracy, of course. It must be a reliable measure for my levodopa levels. Real-time feedback and advice, so I can anticipate off periods instead of reacting. Data I can share with my neurologist to make the biannual appointments more productive and decisions more personalized based on objective data. And data we can share with research people to make it possible for them to do fundamental research to find in the end a final solution. And of course, the ease of use. It should be wearable and unobtrusive, and maybe we can even try to get it all inside a nice, sportive smartwatch. That would be the most wonderful thing I could imagine.
Yes, of course. Thank you so much.
So we mentioned earlier talking about how to also have people continue using the biosensor. So Tessa, based on your research, what drives that long-term adherence in people with Parkinson's disease, and what design choices tend to make this monitoring feel supportive rather than invasive, for example?
Very, very good questions. I think lots of things are already mentioned by the people that live with Parkinson's themselves. But what I do think that is very important is a part of education. So educate people with Parkinson's why it's relevant to measure. Ideally, in an ideal situation, that is naturally to the patient. So you already did some good research about what is relevant for people with Parkinson's. But education really helps. Next, I think, is that they can see their own data and that the data is presented in such a way that people can actually interpret it. So they know what they are looking at, and that might seem very basic, but that can be very challenging based on the data you are retrieving. Another thing that is very important is, for instance, especially when working with biological signals, I think that it's very important that there is also some translation to what patients experience in their daily life to it. So not only showing, for instance, an intensity of a certain signal, but also what kind of symptoms or what kind of things they are less able to do because of that change in the signal. And lastly, I think that, and that's also important for healthcare providers, I think, that if you present data, also present actionable targets. So also alongside presenting the data, present self-management recommendations that are personalized to the data. That keeps people motivated because they can actually do something with the data. And in addition, yeah, I think that that's very important, yeah.
Thank you.
Before moving to my next question, just to follow up. So she mentioned that we still want to keep it simple for the patients to use, apps or devices or biosensors. So I was curious, by showing so much data on your app, would that be sometimes overwhelming for users?
Yeah, I think so. Because actually I now have beta testers. And I already noticed, it's quite different, you know, when you don't have this background. And that's why I think why I stress that there should be this automated report generation. And maybe you can make, say, the simple one, give me the simple one or give me the more complex one. This is actually the Strive PD app. It does this. You can just, okay, I want a report, and then minutes later you get in your email, you get a PDF summarizing things. I think it could be much better than what they give, but so that's the challenge. But yeah, indeed, you could make it a simple one for the people to understand themselves, and the one for the clinician to get the better detail. But for example, what the Strive PD report does is only comparing this month to the previous one. Whereas there's no option, for example, to say, okay, I started medication at this date, and I stopped it at that, or no, I started at that date, and could give me the change, for example. Yep. And then I think that's very elementary, but they don't provide it, so they're losing so much. It's just a simple thing to program, but they don't do it. So yeah, that's out of desperation I started this.
I get it. Yeah. Okay, thank you. My next question was for Ekaterina. Okay, let's say that levodopa could be continuously measured. So how would that change the medical field?
Yeah, that's actually very interesting to dream about because I think continuous monitoring of the biomarker in actually every patient's body would provide personalized information on the uptake of this medicine in the body, because we actually know that this medicine has a really narrow therapeutic window. For every individual patient, we would be able to say how their body is responding to this medicine, and if we need to adjust the medication to actually improve their current state. And that's also not only talking about continuous measurement, but also referring to your roots word about real-time measurement. If we're able to measure levodopa in real time, actually, as fast as possible, we would also be able to control the state of the patient based on the measurements in this specific moment. If we see, for example, a decrease in level, and especially if we associate it with the current physical state, physical symptoms on the patient, we can provide recommendations for the taking another dose of medication or even adjusting dosage. So continuous measurement can actually create guidelines for the improved administration of the drug and improving the state of the patient on a personal level.
Yes, thank you. So it is really important, the continuously measurement of levodopa. You have one last question?
Yeah, so Maarten, PD Trends was developed also to get more details and more access to data. So just to recap for everyone, why is that raw data just so important and that granularity?
Well, first of all, the data on, for example, mobility or like movement, the other apps don't provide that. So they just give you one, so this month you had this much, but they don't show a trend. So I think trend information in general is important. But for the tremor, it also, like if you look at my tremor total it sort of has been the same this year. But if you look at the intensity, it actually changed quite a bit. And this is completely lost in the other apps. So for me, that's okay. It's not a pleasant message, but at least I think I still consider myself stage 1. But at least it gives also the doctor, and it gives you a better idea, a more reliable idea about what is happening, and maybe it can motivate you then to do more things about it. And especially if, so my idea is that if people really see what's going on, they people can exchange about, oh, this is really working for me. I mean, I see Ruud walking in here. He's got. I have 2 years of Parkinson, but Ruud has 8 years, and he looks like a healthy person to me. But actually, he's doing so much exercise, and internally he's motivated for that. But I think it could also help people to remain motivated if they see, oh, it's really working. It's making a big difference to me. Huh? So I think that's really wonderful. I'm a scientist, so I also like to see data. But
yeah. Thank you. And I would actually love to still continue this panel discussion, but we need to wrap up. So I wanted to zoom out for a moment and ask all of you one last question. So for all the students who are watching us right now, and they're going to start eventually also building their biosensors. So what is one thing they should never forget? Just like an advice, for last-minute advice. You can start there.
Well, thank you for letting me be the first. Involve patients and healthcare providers from an early stage to know what you measure and how to present it, and how they can use it in their daily clinic or daily life. I think that's important.
I would like to give advice from the point of view of development of sensors. You need to keep in mind that you're developing a new device, and it will always go along with certain challenges, certain failures, but don't forget what you're moving towards. Remember your motivation, remember the relevance of your research, and keep moving, keep trying. It is definitely worth continuing, and I wish you all the best in your work.
Well, I think the tool should support me by warning me timely when to take levodopa or anything else based on real-time measurements and the best production algorithms. Given the circumstances, it should give advice how to maximize my individual quality of life. Gathering objective data for the biannual visit to the neurologist. Gathering objective data for fundamental research to get more knowledge about Parkinson's and how to solve this complex puzzle and finally cure the people. And an all-in-one concept would be excellent. So if we manage to get all the tools in a smartwatch, why not combine, for instance, the reminders for doing your exercise for less stiffness and other symptoms. In one sentence, it should advise me how to get a maximum of quality of life given the circumstances.
Thank you.
So what to add? I think I have been developing my own sensors, but with live cells, etc. But I think what helped me, and there's now also a spin-out company from that come of it, and it's perseverance. I mean, I've been working on this for 15 years. Now there is a spin-out. What helped me a lot is to think out of the box always, and always, okay, there's a problem, and then just tackle it head on, and but don't think around it and find your solution that way. So 1 year is likely not enough. I took 15 years. So good luck with that.
They can do their best. That's what we're wishing for. That was truly an insightful panel discussion, and I'm so grateful for all the valuable perspectives that were shared today. Thank you all once again for joining us. And on our agenda, we still have one last presentation that would be given by one of our sponsors, Photon Delta.
Photon Delta is a leading ecosystem in integrated photonics, connecting industry, academia, and innovation to accelerate photonic technologies for real-world impact. So let's have a listen to them.
Can you hear me? Hello? Can you hear me? Again? Can you hear me and can you hear my can you see my screen?
Yes, we can hear you and see your screen.
Okay. A full screen or still a partial?
No, still partial. If you can put it on display.
Okay. Is this better?
Yes, thank you.
Okay, then let me get started. So, as already explained, Photon Delta is an organization that is an accelerator for an ecosystem builder for companies active in integrated photonics. I'm Karel de Vries, I'm the Chief Strategy Officer of Photon Delta. And Photon Delta in itself doesn't build anything. We support companies and institutes in developing solutions and going to market. We try to do that by building an economic and ecosystem development system that is a full supply chain, so we can deliver everything. Where we are probably most known for the fact that we got in 2022 a 1.1 billion growth fund awarded to us by the government, which we have been working on since the last 3 years and now entering the second phase, really to build solutions, not only technology. We do that by also having a lot of international relations. We spent quite some energy on market and talent development because without that there will be no integrated photonics. And we have an investment fund where we actually invest in startups that are working in the field of integrated photonics, and there are quite a few medical ones among those. And you can say, okay, integrated photonics, what is this? It is essentially a chip technology. So it is built in the same way as you make the chips that you will see in your computer, your phone, etc., etc. But the different and big difference is they don't use electrons, they use light. And that allows optical functions, which tend to be pretty big and pretty expensive, to be concentrated on a chip, which makes them, of course, small. The integration makes it reliable, it loses a lot less power, and because it is a chip type technology, you have the same advantages. You can make a lot of them, and if you do that, then the price will also become lower. So it is for those solutions that require that, it's really an important development. And medical applications is mostly about sensing. We're also doing things for data centers and AI and stuff like that, but in medical applications, the key is sensing. Now you see here an example of what type of optical functions you can put on a wafer. This is a typical example. You can use waveguides. That's effectively the electrical wire comparable. You can make lenses, filters, splitters, detectors, and in other materials like silicon, you can, like for instance, indium phosphide, you can actually make lasers. And these things are being built in factories, like you can see on the bottom left side. Now, you do this, of course, for a reason. We believe integrated photonics can do a lot to revolutionize a lot of markets, a lot of parts of society, and healthcare is one of them. And you probably have heard it before, but we are dealing with aging populations that require more care. There is a shortage of skilled workforce. Cost is a problem, and every government, and because today a new one, is struggling with that. And it's also, how do you get it available for everybody, not only for the rich? Now, advantages of integrated photonics is that you can make high levels of miniaturization. It is also photonic, so you use light. That means you don't have to cut holes or have contact type of activity. You can do it on a remote basis, you can do it fast, and of course it integrates well with electronics. That means that new developments like preventive healthcare, point of care, and I just heard smart watches and things like that, are becoming relevant, both for home monitoring and for wearables in as well in medical as in well-being type of applications. But of course, it needs a lot of development. And when I started in Photon Delta in 2000, 19, there was effectively one type of sensor already on the market. That's the bottom one, the fiber brake grating. I'll give an example of that in a moment. In the meantime, this list, and I'm not going to discuss it in detail, is what is available on the market, or where we have supported the startup, or where a lot of R&D work is going on to make things available. Unfortunately, given the time, I don't have time to explain a lot of them, but you see examples in many different areas. Let me pick a few, and if you have questions, please come later. The one that is scaling the fastest is from a company that we funded. It's called Multispectra, and they make a near-infrared spectrometer, which is very well suited for vital sign monitoring and all kinds of biomarkers. Depending on the construction, you can measure it also for hydration, lactation, glucose measurements, blood pressure, etc., etc. Because it's near infrared, it can penetrate the skin. And actually, the thing that we're talking about is that small chip you see on the bottom right. That is a few square millimeters, and it is a 16-channel spectrometer. And that is enabling all of these different things. And there are examples in different areas, from well-being to agri-food, in fact. And this company has, in the meantime, got out and said, okay, we will want to build the sensors. We will not do every application. That is just too much for one company, but we will help support kits available for everybody so that they can develop it. And this is a development kit. This one is effectively a few square centimeters. And they made an example of a watch as well. And in that, they can do a lot of application development, or more importantly, they can allow others to do a lot of application development to make actual solutions for customers, for patients. That's one example. Another example, this is the so-called biochip. And a biochip is a diagnostic tool. It is essentially for the technical guys among us, a chip with a very sensitive Mark-Senior interferometer on it. You can make them in very high volumes in bulk, but you put a layer on top that is sensitive to a certain virus, bacteria, poison, whatever. And that is binding to that surface layer, and that is actually changing the behavior of the interferometer. And you can measure that with extreme accuracy. And that allows in atomoles and volumes like that. The consequence is that you have a new, very sensitive and quite fast tool. You need to put a cartridge around it, and you need to put it in a reader, but that allows you to read a number of biomarkers in a few minutes and get very accurate results. So that's one of the other startups that is working on this as an example. And you do that. Now, the other one is, and here I show both the combination of technology development, construction, and different applications, and essentially, because in the end you can only survive if you can sell a few things, if you can actually use it. And it shows you several things. One is you need to develop technology, in this case, the photonic chip. And if you can use that chip for multiple applications, that's really helpful, because then you don't need to spend that much money in development and still support a lot of different use cases. Now, in this case, one of the breakthroughs that is enabling different applications for the last few years in integrated photonics has been the so-called on-chip tunable laser. That's a laser that can change the color of its light by tuning with high accuracy. You can combine it. You always need to combine it with electronics and detectors, of course. But then you have a very sensitive system. On the one hand, we use that for gas spectroscopy, so measuring in gases. The example at the moment is indirect healthcare, for instance, to measuring ammonia in the agri-food sector as a real, and that's a real problem in the Netherlands. But another application of such a tunable laser is so-called spectral image sensing, and then you also use a laser, and you shine on the skin of a patient, so you can do it remotely, and then the reflection that gets back allows you to measure a lot of vital statistics remotely, low noise, independent of the ambience, and also independent on the skin color, which has been a problem in many cases as well. So that's another example of what you can do, and that's another way. There's another possibility with the spectral sensing, by the way. You can also measure blood flow or sap flow in the patient itself without penetrating the skin. The last that I want to mention is Raman spectroscopy. It's a very sensitive spectrum where you shine with a laser on a sample, and you can determine with high accuracy what is in that sample, organic molecules, etc. That has been always big and expensive, and because you use the fixed laser and a spectrometer, and these tend to be big. But by turning it around, changing the color of the light and using a simple detector, you can make it much more. And much smaller means that you can have to think of the size of a finger. You can use it in many different applications, bioreactors, diagnostics. There are several examples where this case comes from IMEC One Planet. They are measuring several things in that in their labs. And all that can then be combined, and that leads to different market possibilities. And blood pressure is one of them. There's a lot of people working on that already. Measuring different materials or different molecules. Glucose is one of the things that a lot of people are working on. It's a particularly hard topic, but also very important given a lot of people in the world that have that problem. So I hope it gives you a little bit of a problem of the problem that we try to tackle by supporting different developments, both in the sense of technology as well as in the sense of how this can lead to market introduction. And as I said, we also support startups in order to make that possible. And there are in the meantime about 10 I think in the medical area, so it's not only theory, it's also practice. With that, I think I've more or less pushed the boundary of my time. I hope it gives you a little bit of an idea of what is possible, and I would certainly encourage you to dream about new possibilities, because the technology is there. It's about defining the solutions. Thank you.
Thank you so much for that presentation. So as we come to the end of today's event, we would like to thank everyone for joining us here, both in person and online. Your participation and the engagement has made this kickoff really, really meaningful. For the teams following the live stream, we do encourage you to join the networking sessions on Canvas.
Could you please stay for a bit later?
You should have received the links and the schedule online. It is such a valuable opportunity to ask questions, to talk with experts, and to exchange ideas with other teams. So definitely stay for that.
Thank you all once again for being part of this event. And we're wishing you the best of luck as you continue building your biosensors. And we can't wait to meet all of you and see all your amazing work during the competition. Thank you all again, once again, for being part of this event, and a very great evening, everyone.